All right, you guys, so we are in Basic Geometry Concepts tutorial. I'm on slide 6, and I'll be going through all these activities, guys, with you as we go so that you won't get completely lost. So we're talking about lines and angles. So line segments are basically part of a line. They've got two endpoints. You put two lines together or two rays together, and you get what is called an angle. So we're just going to get into it. So you see we got an activity here, so you're going to click on GeoGebra. If you haven't gone through my little short GeoGebra tutorial, the video is in my Google Classroom, and you're more than welcome to go through it. Or listen, why not get in here and just play around with it? Nothing wrong with that. So let me scoot back. All right, it says, question 1, plot 3 points on the coordinate plane and label them A, B, and C. Now, does it say where? It just says plot 3 points. So, plot 3 points. So, come over here to your point tool and give me 3 points. I don't care where they go. So, there's 1, there's A, there's B, there's C. And again, here are your coordinates over here. So, that's pretty cool that they give them to you. All right, be sure that all 3 points are not on the straight line. So, they're not on a straight line. Collinear are points that are on the same line, by the way. So these 3 points, A, B, and C, these are non-collinear. All right, now join the points 2 at a time using straight paths. I'm going to use segments. How many unique straight paths can you make through the points? We learned last lesson you can only make 1 through 2 points. All right, so we're going to figure out what kind of geometric figures form. So if you're looking over here, your third icon, I'm going to do segment. Then I'm going to click on A then B, B then C. And don't forget, over here, they're giving the distances for you, which is nice. I'm going to connect C back to A. So we'll notice, hey, this sucker is a triangle. Let me scoot back. All right, so you can only make 1 unique path through 2 points, and the 3 segments make a triangle. And I can't apparently type today. All right. So I submitted. And again, the nice thing about when submitting is it actually does kind of give you an idea of what you're going to be looking at. So there we go. Got a triangle. All right, question number 2. It says the 3 paths intersect in pairs at the points A, B, and C. Measure and record the angle formed by each intersection. All right, so they're looking for angle measures. Also measure and record the lengths of the straight paths or sides. We're going to capture the image and paste it or insert it below. All right, so we've already got the segment measures. There they are right there. So the first one we did was A to B. So A to B is going to be 7.28. Oh, that should have been an equal sign. Equals 7.28. All right, next we did BC. Whoop, wrong one. So BC is 5.83. And then I did C back to A. And that was 10.44. All right, now we got to find our angle measures. All right, so over here, you got what looks like an angle in blue lines with the little pink symbol there. That's your angle symbol. So come down and click angle. Now you have to go in a clockwise motion for this to work correctly. Clockwise, if you've ever noticed a clock, always goes to the right. So if I want to find angle B, then I got to go A, B, C. You see that little angle it forms inside? So angle B is now officially 105.02. So if I want to find C, I got to find B, C, A. And there it is, 42.34. It also gives it over to you on the left side. And if I want to find angle A, then I got to go C, A, B. And there it is, 32.64. So there's my three measures. So angle A is 32.64. And if for some reason you can't see it, you can always come over here to this arrow and click move. And then just come and grab that and kind of move it out to the side so you can see what it is. All right, so angle A, 32.64. All right, angle B, that was 105.02. And angle C, 42.34. All right, so we got our three angles, we got our three segments. Now they want us to capture the image. All right, well, there's a couple of different ways to do this, but the nice thing about what you will be using in class is that these are all Macs. So it's Command-Shift-4. You'll notice you get this little weird icon. So I'm just going to kind of click and drag for the portion I want to take a picture of. And I don't know if you guys heard that, but it sounded like a picture was taken. So again, that's Command-Shift-4. Command-Shift-3 will take a picture of your entire screen. Command-Shift-4 takes a picture of just what you want it to take a picture of. So I'm going to come back here. I'm going to click in my box. Then you got this little icon right here that says Insert Image. So I'm going to click on Insert Image. And I'm going to say Choose File. And I have to go to my desktop because when you're in class, those screenshots will go directly to the desktop. And there it is. So I'm going to click Screenshot. I'm going to click Open. And you get a couple of seconds, it pops right in. And then I'm going to hit Submit. You'll notice if you're working in the same room with someone else that your answers are different than theirs, depending on where they put their points A, B, and C. Sample answer, different from mine. All right, question number 3. Three straight paths A, B, B, C, A, C meet each other at 3 points A, B, and C. All right, so we got a triangle. How do these points of intersection differ from each other? Explain the differences in terms of angles that you see. Also look for the length of the side opposite of each angle. What pattern do you see regarding the measurements? In what situation would all the points of the intersection resemble one another? Modify the triangle in GeoGebra to help answer your question. Well, first off, if I go to what mine looks like, mine is what we call a scalene triangle. None of the angles were the same. None of the sides have the same length. So mine is a scalene triangle. In fact, it's a scalene obtuse triangle because my biggest angle was 105.02, which is an obtuse angle. So I have an obtuse scalene triangle. All right, so let's say if your two segments were the same, you have an isosceles triangle. If you have all three segments and all three angles that are the same, then you have what's called an equilateral triangle. I just happen to have an obtuse scalene triangle. Now it says to explain the difference in terms of the angles you see. What it's asking for you to understand is that, see that big obtuse angle right there, that 105.02? Across from it is going to be my biggest side. And if you'll notice, that was the last one I drew, the 10.44. So a big angle across from that is going to be the biggest side. All right, I also have a 32.64. That's my smallest angle. Across from it will be my smallest side. And since that's the second side I drew, the smallest is 5.83. So that's what it's asking. Across from the biggest angle will be the biggest side, and across from the smallest angle will be the smallest side. That's because those angles create small segments or big segments across from them. All right, if you want to modify it, you're more than welcome to. Or you can kind of go with what you have or even the example that you may be looking at above you. Go ahead and submit that. All right, question number 4. Use GeoGebra to move points A, B, and C to the locations shown by the ordered pairs. All right, so here I am looking at this, A being 3, 4, B being 1, 1, and C being 5, 1. All right, so A, I need to move to 3, 4. So I'm going to come over here, I'm going to move it. 2, 3, 4. So A is now 3, 4. That's one way to do it. B is 1, 1, so you can come over here and type in, well, apparently you can't. So I'm going to swing that around to B 1, 1. And it looks like I have completely messed up my stuff, so I'm just going to start over from scratch. All right, so this input down here, I want A to be at, A was at 3, 4. 3, 4. Close my parentheses. Oh, and I put it at 3, 2. Let's change it to 3, 4. All right. B, I want it to be at 1, 1. So I'm going to enter them down here in parentheses 1, 1. And then C, I want to be 5, 1. So 5, 1. And again, you'll notice I'm putting these as ordered pairs. And I hit enter, and there are my 3 points, A, B, and C. All right, so record the length of each side and measure of the angle in the resulting triangle. Note that the length of the line segment is denoted by the 2 letters with no bar on top. And again, that just means the length of. So I'm going to turn this into a triangle. Come over here to segment. So I'm going to connect A to B. There's my first length. B to C. C back to A. So right offhand, I can see 2 of these are the same. That makes this an isosceles triangle. So AB was the first one I did, and that's going to be 3.61. BC was the second one I did, so BC was the 4. AC was the third one I did, so the third one over here, 3.61. All right, so now we got to find angle measures. The letter in the middle is the one they're looking for. So this one is angle B, the letter in the middle is A, and the letter in the middle is C. So they want angle B, angle A, angle C. So in case you've forgotten, your angle icon, the first one down, you got to go in a clockwise motion. So if I want B first, then I got to click C, B, A. So it looks like angle B is 56.31. Here they want angle A because that's the letter in the middle. So I'm going to click B, A, C. That's 67.38. And this one they want angle C because that's the letter in the middle. A, C, B. And again, it's just isosceles, so it's a 56.31. All right. So it looks like they just want us to do it again. So we're going to change A to 4, 5. I'm just going to move it over. There's 4, 5. B is a 2, 1. Oh, wrong one. Here we go. And C is 7, 3. Well, the nice thing about GeoGebra is that it changes the lengths as you do them. So you still have the measures of A, B, and C, and you still have the lengths in the order that you did them. So my AB was the first one I drew, so I'm going to put 4.47, 5.39, and then 3.61 in that order. 4.47, 5.39, 3.61. Now let's look at my angle B because that's the letter in the middle. So angle B is now 41.63. Okay, angle A because that's the letter in the middle. 82.87. And angle C, 55.49. All right, so I'm going to do it again. Looks like A is going to be 3, 6. So move that over 3, 6. B is 3, negative 2. So 3, negative 2. And C was negative 3, negative 2. All right, so unfortunately, because I had to change things around, I went to the outside. These angle measures are now incorrect. So we're going to probably have to redo those. So angle BCA, CAB, and then ABC. And of course, if you can't see those, I'll move them so you can see them a little bit better. There they are right there. But again, the measures change. So I'm going to put 8, 6, 10. 8, 6, 10. Angle B was 90 degrees. Angle A, 36.87. Whoop. And angle C, 53.13. All right, I'm going to hit submit, you guys. And look at that. Whoop, whoop, gummy. All right, question 5. If you move point C towards point B along BC, does angle ABC change? Now, again, remember, they're looking for that letter in the middle, so they're talking about angle B. How do angle BAC and ACB change? And what happens to these angles if you move C away from B? All right, so we're going to move C towards B. We're going to move C towards B. So I'm going to come over here and click move. C towards B along that same line. The angles are definitely changing. The sides are definitely changing. But does angle B change? No. Angle B stays 90 degrees no matter what. So if I move it over 1, it's still 90. If I move it back, it's still 90. So angle B does not change. Wow, I cannot type today. There we go. All right, so what happens to angle A? Well, here's angle A. You're watching the 41.19. So if I move it over, oh, it gets smaller, 36.87. Move it over again, 32.01. So it looks like angle A gets smaller. Let's see what happens to angle C. Well, it was back here, so 45, now it's 48, now it's 53, now it's 57.99. Angle C is definitely getting bigger. All right, so that was going towards. So let's see, if C is moving away, then I guess it would just be, yeah, opposite, right? So if it was moving towards, A was getting smaller, but if it's moving away, angle A is going to get bigger. Angle C gets smaller. Angle B still is not going to change. Still going to be 90 degrees no matter what. All right, I think this is the last question. All right, so we're going to delete AC. All right, so you don't know how to delete any of that. We're going to delete AC, so you're going to click on AC. which is the hypotenuse, and you're going to hit delete. So let's go. And focus on the intersection of AB and BC. All right, so we're going to focus on the intersection of AB and BC, which is that 90-degree angle right there. That's the intersection. Intersection is where they cross each other and where they intersect. All right, keeping points B and C fixed, move point A to a different location and observed what happens to angle B. So we'll move A. All right, so it looks like B changes. Okay, so depending on which way you move angle A, then angle B will get bigger or smaller. All right, well, so what happens if you move angle A directly on CB? Well, let's do that. Let's click on angle A, put it directly on CB. Bam. I don't even have a triangle anymore. Looks like that angle B is going to be, well, 0 degrees because there's not even an angle there. All right, so I don't know, self-evaluation, I rock that. I hope you guys kind of understood the lesson as we went. If you're in class, you're more than welcome to ask me questions. If you are a remote learner, send me an email or a message, you guys. All right, hit submit, and I will see you later.